Today, on How It's Made. Automatic transmissions. Silver miniatures. Hot air balloon baskets. And darts. Your car's all-important transmission is a system of gears and levers that transfers power from the engine to the wheels. With a manual transmission, you have to shift the gears yourself. But with an automatic transmission, the car's computer determines when it's time to shift and sends an electronic signal to activate or deactivate the appropriate gear. The transmission allows the engine to operate in its most efficient range or power band. It's assembled inside an aluminum housing called the transmission case. At the heart of the transmission are 3 sets of planetary gears, so named because there are smaller gears rotating around a larger central gear. The first gear set is called the final drive. It harmonizes the engine speed and driving speed. The final drive is attached to the differential, a component that lets the wheels move at different speeds so the car can turn. Workers install the steel parts connected to the shift lever, which puts the car into drive, reverse, or park. First, the manual detent lever. Then, the forward clutch support. The piece protruding from it is called the park paw. The actuator rod connects the detent lever to the park paw. It locks a gear that immobilizes the car when you shift into park. Now for the transmission's 5 clutches. Depending on what the transmission needs to do, clutches either let gear sets rotate or lock them in place. This clutch is called the forward clutch. By moving the input gear set and the reaction gear set, it enables the car to go forward when you shift into drive. Two clutches installed as one unit go in next. The coast clutch allows the car to coast in low gear and to brake progressively in higher gears when you take your foot off the gas. The second clutch is called the direct clutch. It locks the 2 gear sets so there's no reduction in speed. Next, the reverse clutch. It moves the reaction gear set so the car can back up. A clutch is made up of layers of metal and friction material, such as resin-impregnated paper. The transmission's second clutch uses both the input and reaction gear sets to switch the transmission into second, third, and fourth gears. With all the gear sets and clutches now in place, workers can connect the transmission to the rest of the car's electronics. These cables are known as the harness. Next come the drive chain and 2 sprockets. This hookup is the critical link between the transmission's gear sets and its torque converter. The torque converter is the component that transfers power from the engine to the transmission. The sprockets in the final drive convert the engine speed to the appropriate transmission gear. The car's computer directs this hydraulic control system to change gears as needed. The computer triggers an electronic switch, called a solenoid, to open a specific control valve. This applies hydraulic pressure, which engages the clutch around the relevant planetary gears. When the hydraulic pressure is released, it disengages the clutch and locks the gears. Now the final connection for the shifting mechanism, linking this manual valve to the detent lever. The shift lever moves the detent lever, which makes the valve direct hydraulic pressure accordingly. This steel bar, called the output shaft, directs transmission power from the final drive at one end of the transmission to the driver's side front wheel at the other end. Next, workers install springs and servos, part of the hydraulic control system that helps engage and disengage the clutches smoothly. This tube assembly goes in next. The control valves route hydraulic fluid through these tubes to the different clutches. Now the torque converter. It spins a shaft that turns the sprockets and drive chain that we saw earlier. A steel bar called a stub shaft is the final link, sending transmission power from the final drive and differential to the front wheel on the passenger side. Up next, making silver masterpieces on a miniature scale. Collecting and displaying miniatures isn't just child's play. It's become a serious hobby for grown-ups who even buy fine silver in miniature. Avid collectors spare no expense. Because after all, it's the little details that make the difference. In the world of miniatures, there's no need to downsize one's expectations. Here you can find all the little luxuries. This silverware is no cheap reproduction. It's a tiny version of the real thing. To make it, silversmiths use tools and techniques that have been handed down over generations. This is a workbench from the 18th century. Today, they use one that's nearly identical. To make a miniature mug, workers begin by dividing its measurements by 12, so that the finished product will have the same proportions as the original. Next, a strip of silver is rolled out to about 2/100ths of an inch thick. Then, small round discs are punched out. A blast from a torch softens them so they'll be easier to work with. A dunking in acid eats away any impurities and leaves a frosty finish. One of these discs is set on a lathe. As it spins, a series of tools begin to give the thimble-sized mug its shape. Any mistake is a big one when you're working in such tiny dimensions, so the silversmiths have to work with great care. During the machining process, the frosty finish left by the acid is removed. The mug is buffed to add luster to its finish. And now it's time to make the mug's base. It's tapered to make a perfect fit. Small fragments of silver solder are placed between the two pieces. Then, the parts are heated to almost 1500 degrees to fuse them together. Next, leftover silver pieces are cut up, and the scraps go into a crucible. A pinch of borax is added. This mineral will prevent unwanted oxides from forming as the scraps are melted down. Silver is far too precious, so workers don't want to waste even a single scrap. The molten silver is poured into a plaster mold. Then the mold is plunged into cold water. The temperature change causes the plaster to explode, exposing 3 tiny silver handles. One of the handles is soldered onto the little silver mug. And now, all the pieces of the miniature are in place. Next, the miniatures are placed in a bucket of steel shot and soapy water. The friction cleans and polishes them. The soapy water is strained out and the gleaming miniatures are revealed. Each silver miniature has to meet the same purity standards as full-sized silver pieces. In this factory in Britain, the regulations have been around for 700 years. The maker's mark, called the hallmark, is the stamp of authenticity. Hallmarking a miniature can be a bit awkward, and some articles are just too tiny to mark. When it comes to replicating silverware, it seems no job is too small. And there are plenty of shining examples in the world of miniatures. When we return, behind the scenes at a hot air balloon factory. Next, the art of the dart. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at sciencechannel.com.